In this video, I'm going to explain about some important terms used in coordination compounds. The first one, ligands and central metal atom or ion. What are ligands? They are the donor atoms, okay, donor atoms. They are those which donate a lone pair of electrons to the metal atom or ion and then form a coordinate bond with it. So those are known as ligands. Whereas the metal atom or ion to which these ligands are attached is called the central metal atom or ion. For example, nickel tetracarbonyl. Nickel is a central metal atom. CO molecules are the ligands. They donate lone pair of electrons to the central metal atom. Okay, so we can also say that ligands, okay, ligands are Lewis bases because they donate a lone pair of electrons to the central metal atom, whereas the central metal atom is also known as a Lewis acid because it accepts a lone pair of electrons from the ligands. This is just a simple example of a ligand and a central metal atom. The ligands may be simple ions such as Cl- or smaller molecules such as H2O or NH3. It might also be the large molecules such as ethylene diamine or macromolecules such as proteins. Okay, and in every ligand you will see that nitrogen and oxygen are present. So nitrogen and oxygen are the most common donor atoms in ligands. Now we come to these unidentate, bidentate, and so on. A ligand may contain one or more than one donor atom. If it contains one donor atom, it is known as unidentate or monodentate. Examples are NH3, H2O, Cn-. Here the donor atom is nitrogen, here it is oxygen, here it is nitrogen. And then bidentate, if a ligand contains two donor atoms, then it is known as a bidentate or didentate. Examples are ethylene diamine, oxalate ion. Then, if the ligand contains three donor atoms, they are known as tridentate or terdentate. If 4, it is tetradentate. If 6, it is hexadentate. Example of hexadentate is EDTA, which is ethylene diamine tetraacetate. And if it contains many donor atoms, then it is called polydentate. Okay, so let's come to the second one, denticity and chelation. Now we focus on the bidentate ligand, those ligand which contains two donor atoms. The ligand may contain two donor atoms, that is coordinating groups, and such ligands, when they are attached with the central metal atom, they position in such a way that a 5 or a 6 membered ring is formed. Then it is known as a bidentate or didentate chelating ligand, and the ring is called a chelate ring, and the resulting complex that is formed is known as a metal chelate, and this property is called chelation. Okay, I hope you have understood about that one. Whenever a bidentate ligand is linked to the central metal atom, then it positions in such a way that a 5 or a 6 membered ring is formed, and this property is known as chelation. Then what is this density? Density actually refers to how many coordinating or ligating groups are present in a ligand. It means the number of coordinating or ligating groups present in a ligand. Now we come to a few examples of chelation. The first one is didentate chelation. Didentate ligand is a ligand containing two donor atoms. Examples: ethylene diamine. Here we see that there are two donor atoms, so it is an example of a didentate ligand. This one also is an example of a didentate ligand. So in a didentate chelation, what happened? A didentate ligand is there. So look here, this is an example. Platinum is the central metal atom, and then we have ligands Cl. We also have a didentate ligand. This would be your di-dentate ligand, ethylene diamine. See, a di-dentate ligand forms a 5-membered ring with the central metal atom. So this is an example of a di-dentate chelation. Now we come to terdentate chelation. Terdentate means tridentate, 3 donor atoms, 3 donor atoms. That one, platinum, and then we have Cl, and then we have this one, this ligand, a tridentate ligand, NH2, CH2, CH2, NH, CH2, CH2, NH2. Okay, like this. So this one is this. How many donor atoms are there here, or the coordinating groups? 1, 2, 3. Those which are attached to the central metal atom. So it is an example of a tridentate or a terdentate ligand. Then we come to this one, tetradentate chelation, this example. This En is ethylene diamine. Okay, so let's draw the structure. We have platinum, and then we have a tetradentate ligand. 1, 2, 3, 4. Tetradentate, 4 donor atoms. So we have NH, CH2, CH2, NH. Here we have NH, CH2, CH2, like this, and then here we have CH2, CH2, NH2, like this. Okay, so let me draw it properly here, NH2. So this one is this. Okay, how many donor atoms? 1, 2, 3, 4. They are all attached to the central metal atom. So this is an example of a tetradentate chelation. I hope you have understood about this one. That's all.